They are now. Welcome back to the workshop. So today's episode is the final episode in the straight cut gearbox build that we started about 6 weeks ago now, probably, or a little bit more. I had a bit of requests, or a few people have been asking me, did that gearbox get finished? And no, I've been saving it for you guys, of course, and we're going to put the finishing touches together. So the last few bits and pieces to do on the box, when you guys left me last, we had a very good conversation about limited slip differentials, all the different kinds of differential options there were. And we said that this one was running one of the older type Salisbury differentials, which we have now fully rebuilt, put that together. I've done the modifications to it that I wanted to do. The ones that I talked about, changed the ramp angles a little bit and changed the preload on the diff a little bit. So this will be a monster now when it goes back in the car. How long it'll last as a monster? Well, that's Salisbury differentials, but it'll go very well on track when we go there. So next job to do is to install this differential into this gearbox housing. Now, a few different bits and pieces that we have to get into check. The very first thing you have to do is make sure you've enough clearances. Having built so many of these over the years, I've already ground away the material that is required to get those clearances. But things you have to be very careful with these differentials is the bolt pattern here can come very close to the casing in these two places here. And then in another spot where they oftentimes see a lot of rubbing is on the lugs inside here. So they've all been ground out, and we've made the space in there for them to give ourselves hopefully enough clearance. So when I'm fitting these differentials into these gearbox housings, there's a couple of things that you need to get to happen, okay? I'm going to want to put bearing fit on these bearings to make sure that they stay in these housings and don't move. Before I do that, I want to make sure that I'm going to have the differential in the right place when I do that. The only real way of doing that is to put on the side casings, because the side casings decide where this differential sits in comparison to, I suppose, actually across the box. So there's a ridge here on the side casing, and that ridge is what sets the clearances across here. What we ideally want is we want the diff to sit up as close to that housing as possible. So keep edging it over until the housing comes and sits in there. Now, I know from past experience, having built these a good few times, that you can't actually get a Salisbury all the way over, because if you get it all the way over, it actually hits the web on the inside of the box. So what I normally do is I add a couple of shims to this size. How much? Typically speaking, 0.5 millimeter, 0.5 millimeter, somewhere around there tends to normally get us out. I'll tell you now exactly what this one is. So we've got 0.65 of a millimeter in shims there, which will be more than enough. Put our housing in there and make sure that our diff bearing is up against it. Okay, I'm happy with that. Now, before we can actually properly install that housing, I now know that that is where I want the diff to sit. So what I'm going to do is I'm going to take the diff out, and I'm going to put a small amount of bearing fit on this side, on this diff bearing. Can't do it on this diff bearing because we need to set the preload, and I'm going to show you how to do that in a moment. So only on this side. We can put the bearing fit for the other side on the top housing when it goes on. Bearing fit is pretty straightforward. You just want to put enough on there that's going to pick the bearing up, but not so much that is going to squeeze out everywhere, because bearing fit is actually a cement. So if you have a cement like that squeezing around, it can cause problems inside the gearbox. Okay. Now, no problem with getting that bearing fit hard in that housing, because when preload is set, this diff actually is going to float. I'm going to show you a close-up of that now in a moment, and you can see how that diff can actually float at the moment, even though I'm holding this bearing down tight. Okay, next, before we can button up this side plate, I've put on some sealant on here. We've got to put in the detent sleeve. That sits in and stops the cross slide from moving, while the anti-2 balking slide from moving. Next, what has to go in is the ball bearing and then the spring. There is also an O-ring around there, and that O-ring is very important not to miss it out. I always put extra sealant around after I put the O-ring on. Now, no sealant on the actual housing. Never do sealant on the housing. Anytime you're going to fit a housing, you need to make sure that the clearance in there for that bearing is good. I've changed these side cover bronze bushings, so I know those clearances are right. But if you're just rebuilding the box and you haven't got that done, then you need to test it. If you're not sure, bring it to the machine shop or bring it to your gearbox builder, and they're going to know what size they should be. Okay, get that housing in. There's two ways around that housing can go. It can go on the box that way, or it can go on the box that way. In the case of this, that is the piece that is going to hold that spring in and hold that detent in place. So it is in this orientation we want it to go on. In the case of this one, you can button this up completely. You can put the 2 bolts in where they need to go, and you can button them up completely, because for this one, or in this case, there's no movement going to happen. For the other side, I'll show you, we won't put the sealant on straight away because there is some movement going to happen. Okay, how tight should these bolts go in here? Generally speaking, the torque specifications are available in a few different places. What I like to do on these, I put 11 Newton meters on them and then turn them through 90 degrees. And that gives me the same torque specifications out there. I'm pretty sure the original OE factory spec is like 23 Newton meters or somewhere around that kind of number. The length of these bolts is critical, guys. If you get the length of these bolts wrong, the bolt protrudes, pushes out the inside of the gearbox and breaks it. So make sure you check to know that you have the right length bolts. I've actually modified all these bolts because we have a limited slip differential here now, and the limited slip differential is going to have material machined like we've seen a few minutes ago out of the inside of the casing. Therefore, with that material machined out of the casing, the bolt could potentially protrude into the housing easier. I'll show you an example now on this diff housing just once I get this one torqued up. Okay, just before that bearing fit sets off, I want to make sure I get this differential over where it needs to be. Now, that's pressing hard up against that seal, which is exactly what I want. So what I was saying to you about the bolts protruding, that is a bolt hole there, which is coming through from one of the sides, and you can see that we've tinned that down. So by tinning that down, potentially if you put the wrong bolt in, it'll actually come right through the housing. And if it does, it's going to come in and lock your differential up, and you'll wonder why your gearbox isn't turning. Okay, the next clearance we have to test here is going to be what we call the nip. Now the nip is basically a clearance that is brought in by this housing pressing in here and pushing the outer race of this bearing towards the outer race of that bearing. The specifications vary out there depending on your box, so you need to look at the owner manual and make sure that you get the right bearing nip for the bearings you're using. In the case of these here, I'm using a Nippon Denso bearing that I have picked out myself. Me and my bearing supplier have come up with the right bearing. I've come up with it, and the nip we're going to use here is 5 thousandths is the nip that we use. This all depends on whether you have a gasket here or not. I always run my race boxes without a gasket. I just use the sealant. I don't use a gasket. Other people want to use the gasket, and if you're going to use the gasket, you've got to check your nip with the gaskets in place. In this case, we're only using a silicone sealant. I run a nip of 5 thousandths, and I'll explain to you later on why that's so high. The reason for it is, why that's low. The reason for that is because when the silicone goes on and seals, it's actually going to take up a small amount of space, and it's going to change that nip. So how we test the nip, we've got to put the differential housing on this time. differential housing just literally slides down. You'll remember in a video previous to this, we actually want to make sure that we're sitting on our dowels, which we are. We machined this differential housing to this casing specifically for this job. Next to go on then is the nuts. You'll notice that these are a little bit unusual. I actually use a head stud on this side. These are our Mini Spares Evo head studs is what I'm using on this side. And I use a stud I make myself on this far side, which are made out of the same material, that EN21, that these Evo studs are made out of. And I use these roll thread nuts. Trying to get these differentials to hold together is very important, or trying to keep these to hold together. There's huge forces on these in the likes of a race or track motor, so making sure that you have the best fasteners here that you can have, or the best fixings that you can possibly have here, makes a huge difference. So using these good quality nuts, using these good quality fasteners ensures that these boxes hold together for me, and I get a good fastening. It also helps reduce or mitigate oil leaks. Now, I'm not torquing these because I just want to nip these down to make sure that I have a good setting on here, because I'm just checking a clearance at the moment. Okay, I'm going to put one bolt in the top of this cover here just to make sure that I haven't pressed up tight against those bearings. So I'll put that in and we'll torque that again to the clearance that we did the other two too. I haven't put any silicone sealant on this housing or on the top of this housing because at the moment I'm just getting this thing dry set up so I can do my clearances. I'm going to leave these reasonably slack. They're just nipped down because I want this bearing housing to be able to move here. If that bearing housing isn't able to move, what can happen is you'll get a wrong reading. When you put the box back together, put all your silicone sealants in, you nip up all your bolts, you drive it down the road and those bearings come together and you lose your preload on your bearing. So leaving these a little bit loose is very important because it just allows you to make sure that you can get that nip when you need it. So bring them down snug and tight and then just back them off so that they're just barely nipping that housing so that we know it can move. We want it to be able to move. So now I know those inner bearings can move. Before I go putting the housing on it, a little bit of a punch just to make sure that that bearing housing or that casing is moving, and I'm watching it move there, which is exactly what I want. Now, what we need to do is put a known thickness in here. I'm just going to go with all of these. It's important that you make sure that between each one of your shims that you're putting in here, that there's no dirt or muck between them. So take each shim apart and clean it. If you've got any dirt or debris between your shims, that can give you room for error, or it can give you room for there being a problem. The dirt moves around, it washes out, washes in, and then something moves and your clearances change. So it's really worthwhile just keeping everything thoroughly clean. Even though I've wiped these all before, they've been sitting around here on the bench for a while, so it's worth giving them a second wipe. Okay. Put them together, get your micrometer and check and see what it is you have for a clearance. So what I have there now is 1mm 0.25. That's the thickness of that shim packed together. That's 1mm 0.25. It's important we keep that number in our heads. Now as I look at this and I see 1mm 0.25 is actually bringing me really close to the edge there. So I'm going to come back off that a little bit. I'm going to probably come back to a millimeter here. See what this is. That is 0.85. Okay, let's come back to 0.85 and see where that leaves us. Okay, so 0.85 now makes me see that I'm at least below the edge of that housing, which is important because I want this to centralize on the housing. If you have a problem, lads, where those move around like that and it's hard to actually get that housing in there, you can put a smear of oil or grease on them, just to guarantee that they sit into place or they don't fall out on you as you're putting them in. I most times like not to do that because it can affect the clearances, but it can be quite a struggle if you don't, so it might be worthwhile. Now, a couple of bolts into these, and we just nip them up. Okay, the next thing we have to do now is check and see what the space is between this housing here and this face here. That space is what we have left over, basically. So the bearing pack that we measured was 0.84 of a, sorry, the shim pack we measured was 0.84 of a millimeter. Whatever is left here is going to tell us how much of that shim pack is sticking out. So let's just say, for example, we have a space here now of 0.4 of a millimeter. That means that if we took 0.4 off that shim pack, this housing would sit dead tight up against that bearing and hold everything together completely straight. If we want to have 0.05 of a millimeter nip on the bearing, my apologies, I may have said thousandths earlier on. Typical of me getting mixed up between my inches and millimeters. 0.5 of a millimeter, sorry, 0.05 of a millimeter nip is what I'm looking for here. Then if I wanted to get 0.5 and we have a space here of 4 millimeters, then I just have to add a 0.5 shim to the 4 millimeters. So if I had, sorry, 0.4 millimeters. So if I had 0.45, that would give me my 5,000 nips. So let's measure and see exactly what that space is. So start off there. So that's a 0.63. That's not making it in there. So let's come up to, let's add 0.1 to that and see where that gives us. Okay, that's just starting to get tight there. So what have we got there? That's 0.7. Let's add 0.05 onto it now and see if that gets us there. It's important you don't check at the bolt because the housing bends slightly at the bolt. So you want to check in there in that middle section in there. So let's come another small bit there. Okay, that's exactly what I want now. I just have some drag on the feeler blade. Now, just to be sure, I like to measure the feeler blades against the measurement I had, rather than going by the number on the feeler blades. To be honest with you, it's probably fine to go by the number on the feeler blades, but I just like to go that extra little bit. Okay, so the number I'm getting there is 0.75. So what that tells me is I put 0.85, was 0.84 actually, I think it was 0.84. We'll measure again, we'll take the shims out and we'll check again. I think it was 0.84, but we'll look at it now. And the space that is left there now is 0.75. So what that tells me is that there is actually only a space left in there between that housing and the bearing of 0.1 of a millimeter. So if we put a 0.1, if this is the case, we'll do the maths and check it again. But if we were to put, in that case, another 0.5 of a millimeter or 0.05 of a millimeter shim in there, that would give us the nip we want. I'm going to whip this back off again, check my measurements, and I'm going to come back to you and I'm going to give you the final result. Okay, so I did my measurements and we had 0.9 of a millimeter shim stack in there. When we did the measurements with the feeder blades, we got 0.8 was the space, meaning that the amount of space that's left on the inside is 0.10. I decided to come over and do a drawing for you to give you an idea of what I'm actually doing. So, rudimentary drawing. These are your diff covers, the aluminium diff covers. These green lines represent the shim, and then these black portions here are the bearing. Basically what we're trying to do is we're trying to get preload on those bearings. Sticking out of our diff covers are these little blocks, which is that ring, that raised ring in the diff cover. And it's going to come up and sit against the bearing housing here and here. This is obviously a cross section. So what we did was we put a bunch of shims in there and then tightened up the diff covers, and we measured to see how much the diff cover was standing off of the diff housing. That was where we got that measurement of 0.8 of a millimeter. We knew that the shim stack that we put in there was 0.9 of a millimeter, meaning that if we took all the shims out, there would be a space between the diff cover and the bearing of 0.1 of a millimeter. The preload I want to put on the differential bearings is 0.05 of a millimeter, a half of 1/10 of a millimeter. So that means that I needed a shim stack up of 0.15 millimeters, and that would preload my bearings with the amount of preload I want. Let's go back over to the Gearbox and see how that worked out. Alright, just before we go back at this, just thank you very much to everybody who is new to the channel. You're most welcome. Enjoy watching the show. Have a look around at some of our other videos, and if you think we've deserved it, give us an old subscribe, bang the like button, and don't forget to hit or give us a comment in the comment section below if you want me to clarify anything you heard me talk about today. Have a chat with us or ask us a question. We love hearing your comments. We love talking to you and seeing you guys on the channel. Also, just as a side note, the 1 year anniversary of the channel is coming up on Monday the 15th. So thank you guys so much for giving us a year of absolutely great fun, loads of feedback, so much support from everybody, either on our buying our merch on the website, getting the donations through our coffee account, and just generally hanging out here, giving us comments and giving us feedback. As I said, we started this channel a year ago to share what we do here in the shop with you guys, so that you guys could come hang out with us. Did we think we would have nearly 3,000, I think it's 500 subscribers or somewhere close to that now a year ago at this point in time? No, we had no idea. So thank you so much, and it is great, and we do appreciate everybody that's there. We see all those new people popping in every day, and we love having you there. Speaking of new people, we have a different camera operator today, so all that shaking, vibrating, rattling and rolling around is not Billy's fault, it is Dara's. Everyone give Dara a wave in the comments. Say hi, Dara. Alright, get back to this Gearbox. So right, I've put the shims in place. The boxes, this side is shimmed up, this side is shimmed up, and just before we put on the top gear housing, let's just check, make sure that our diff is turning free, and it is. It's turning lovely and free through the box. We know our preload is going to be right. Now the preload will come just slightly more when we put the top half of this diff housing on, but it's going to work out that way. People often ask me, what do I use as the sealant for this? Plug for Tiger Seal. I know they don't pay me anything or give me anything for this, but we use Tiger Seal on the gearboxes. I use Durco on the engines, but I use Tiger Seal on the gearboxes. It's a PU silicone, and it seems to put up a little bit better with the movement. There's a lot of movement in the covers of these gearboxes, and this silicone just seems to put up, or this sealant just seems to put up a little bit better with it. We've had better success over the years with keeping the box sealed, and you know, having less problems with it leaking, whereas the Durco, while it seems to work initially, it seems to probably have more problems down the line, where, you know, starts to get more problems. I'm just going to bang another bit of sealant onto these surfaces, and then we can get this diff cover on and get this box finished up. So what you'll notice is I put the sealant on all of the diff cover faces, because I like to have everything kind of in place and where it needs to be, and then just slot these housings in. It's no harm just to slacken those bolts slightly just as you're dropping the diff housing in, so as not to scrape off this gasket sealant. There's 100 different ways to skin this cat. This is just how I do it, and it has been very successful for me over the years. Sorry to all the cat lovers, I'm not actually going to skin a cat, but yeah, there's a load of different ways, and this is the way I like to do it. And as I said, it has been very successful for me in the past. People ask me why I don't use gaskets. I don't like using gaskets on anything kind of racy, or anything that kind of has a lot of possible flex or movement in it. On a, you know, if I was building a road motor or a very standard road motor, I might well do a gasket in that situation. But in a situation like this, where I know there's going to be huge forces and stresses on the engine, I'm much more likely to go this way with it and use this as the way to go on it. Okie dokie. So, last thing to do just before we finish this out is to put a little bit of bearing lock. I like to put bearing lock on here, just to make sure that these bearings don't move or don't seal. So before you seen me doing this on the other side, but for these ones I always do it on the top of the bearing. So just a small dab along the top of the bearing, just so that when this housing goes down into place, we are sure that it's going to grip and it's going to sit where it needs to be. So get this guy in here. Let's take that exhaust off now while it's nice and easy. Into place our copper hammer. Make sure that's down where it needs to be. Put these diff housing bolts on. So I torqued these to 25 foot-pounds and turned them 90 degrees. That's my own figure. I'm not going to recommend that you do that. I know my fasteners. I know how everything works and how I've built the box. What I recommend you do is that you look the torque setting up on the data. You can find it over Classic Mini DIY has a great service over on their channel where they have all of the torque specifications for pretty much all of the engines and gearboxes out there. So head over there to Cole's website and you'll find those figures there, and use those torque specifications. It's just how I do it. Before I put the last couple of bolts into that diff housing, again, just nip them up, check to make sure the gearbox spins freely, which it is. And lastly now, put our couple of diff cover bolts in place and on. Once we have all of those in, then both sides, all we have left with is to put the front cover on, and then this gearbox will be finished. It'll be complete and it'll be ready to go. I'm not going to waste any more of your time watching me put nuts and bolts into gearboxes. Hopefully you enjoyed coming along with me and watching one of these race gearboxes getting built and put together. Any questions people have, bang them in the comment section below, and I'll be more than happy to have a chat with you there, talk about the different possibilities or problems that you might have with your box. Have a look at the different situations. There's a couple of more videos in this. We'll put the last video in the series up in the corner, and you can follow back to our playlist, which is back on the main channel, and see the whole gearbox build video. I'm sure Billy can make a playlist for just the gearbox build video. Yeah, he can. He's nodding here to one side. He's in a directorial role while we have our new cameraman this week. Don't worry, it'll be all back to normal. He'll be back working nice and hard the rest of the week. Alrighty, I'm gonna leave it at that. I'll see you guys in the next video, and thank you very much for watching.